Got our SR20 custom rotor group in, and this thing's been VSR balanced, so you can see remnants of the brass bearings on the turbine shaft here. So we'll polish that up before installation, and it's all been marked up for orientation. The reason I've got both apart here is because this TB25 GT25 rotor group requires a heat gun to separate our compressor wheel from turbine. So let's take a look at some of the differences here. I guess we'll start on turbine side. So essentially the same wheel. The only thing that's been done here is a bit of slimming through the nose section. The blades are actually slightly thicker, so there will be a slight increase of mass. We'll weigh that shortly here, but we've decreased the nut size to try to overcome that, remove some material in the nut area. But true Inconel, just like stock. And in doing research, I found that above about 16 psi, there are some turbine failures. So the heat on this thin metal makes it brittle. You know, combine that with out of balance, high speed vibration, things start to come apart. So hopefully this will be a little bit more durable without losing too much spool. But I'm fairly confident that the weight of the total assembly is going to come in about the same, given some of the mass reductions we've done on the compressor side. So looking at compressor, this is where the notable difference comes in. I didn't want to get too crazy with compressor side modifications because, again, I found that guys with S13s running the 2-liter engine are seeing boost creep above about 15 psi, 16 psi. So loss of gate control. We'll do some gate modifications to help with that. Just make sure the actuator is working very rapidly and accurately. But really, the compressor side is outflowing the housing and turbine. So turbine housing modification is going to become very important on this build. But really, I'm just doing this for you guys, for YouTube content. I'm not sure I have a build that's seeking kind of a 250 wheel horsepower maximum. But it's a real interesting look, and what I'm most interested in is I've got a blown RB25 turbo, and I'm wondering if perhaps our TB25 Garrett wheel is a replacement for that ceramic wheel, so that there'll be an upcoming video where I use our original SR20 turbine to make those comparisons. I've already got our center housing rebuilt. I'll take a look at the different bearings that are available for this shortly. But we've upgraded this to a 360 thrust, similar to the kit that I'll show. And there's some differences to be aware of in journal bearings that come with these kits. You'll notice I've got some orientation marks on the housing. The collar was also balanced with the turbine and compressor, so we've preserved that orientation here. Let's take a look at the bearings, and then we'll take a look at how we've modified housings and slap it together. As a reminder, our stock 270 experienced a bunch of cracking. So this thing is barely held together now. You know, this piece has got a crack like that up into this bolt hole, and it's just that small outer tang on the bolt hole holding this whole thing together. So if that had fully come apart, that would have been catastrophic. However, the wear seems pretty normal, and the turbo, if you look at our original teardown video, spun totally fine. So I didn't suspect that I would see this upon tear down, but it's very good that we are rebuilding this without a doubt. So clearly there's some thrust load issues, and that turbo had probably been run very hard originally. So we're going to a 360 style thrust, and for that you're going to need a 2-piece collar in order to sit in front and behind, which should come in the kit. But we've got a single kind of generous oil orifice, should be sufficient, and then some nice kind of oil machining on both thrust faces for retention and flow. So that should be a solid upgrade. For bearings, you will see that there are two styles. So getting a look at these, on the left you've got kind of a standard replacement with small oil orifice, and on the right you've got a high flow version with much larger oil orifices. So we're going to be upgrading to the large oil orifice size, and it's already been installed in our center housing here. So be aware of that. And then the second thing is you'll notice that often there'll be 4 bearings in a GT25 or GT28 rebuild kit. And the reason for that is that one is significantly taller. And your taller style is going to be used in a DSM application. So OEM Garrett DSM turbos. You are looking for the shorter one. The other way to identify them is the short one has like a bit of a machined groove. So there's a machine step down versus the DSM does not. So you're looking for the bearing with the step that is shorter total width. And then last thing to mention is that the original turbine side outer circlip, so if you can see it there, I've reused one of the 4 standard inside diameter circlips that come in the kit, but it's not wide enough, you will find. So what you have to do is just take your outside circlip tool and then use it to spread that circlip to gain some OD, enough that it'll clip into that groove. And that'll save you a lot of trouble, because I've not been able to find a kit that has that standard OEM style kind of spring circlip that we tore out if you look at the original teardown video. You'll find that a lot of the parts in these T25, GT28 rebuild kits are not Nissan specific, but you can make do, and you will get a rebuilt turbo out of that very cheaply. So your typical kit that's going to be on like Amazon is going to have the small oil orifice bearing. They will work if you're looking for the upgrade. Go 360 thrust and get the large style oil orifice. Taking a look at housings. So I'm not expecting to use this on an SR20 application. It's likely going to go on a K series, something else. So we've done the billet universal conversion inlet and outlet. Obviously ceramic coated it for a bit of thermal protection and honestly looks, corrosion resistance. And then simply porting the entry from our billet inlet. There was originally a ridge here. I've tapered that in to our stock diameters, and we didn't really change those diameters much because, again, our concern on this turbo build is less on compressor side, which is proven to outflow turbine, and more on turbine housing and gate control. So similarly, just a taper in and, getting down, getting all that casting flash, smoothing out on the compressor side. This will increase flow ultimately. But we're not killing ourselves on porting on this housing. And mostly just try to do a good job of cleaning up any casting defects for looks and making this thing really outstandingly shine. So there's a bit of a looks mod and some minor modifications to make the universal flanges fit primarily. And then the real focus of our R&D on this one is our turbine housing. So just got the carbide bolt cut done, and I actually ran out of sanding cones, so it's kind of half sanded. But we'll put it into its final shape. But what I would point out here is that we're going for just a full area port. And this may match up with our T25 housing we took a look at about 2 days ago. But you can see I've kind of marked out some areas where there needs to be an additional bit of trim. And the one thing to be aware of with this particular GT25 housing, so on this bottom side, there are these bumps. And what they are is indentations to afford for this bolt area. So I didn't want to carve out those bumps and weaken the integrity of this wall, right? I wanted to preserve the thickness in this area, but we didn't have that problem over here where there's actually very abundant metal thickness. So in the area of that T25 inlet, I've done a lot more shaving and tapering in this side than I have in this side. Here, all I've done is kind of smooth the entry in and over that bump, which is all we're going to do. And then we'll take the majority of the material out of this section here, going down as deep as we can. And if you look at this housing in the teardown video, you'll probably notice the difference. We've taken out some pretty significant material. So effectively increasing the AR of this housing. Looks like it's a 0.64 as OEM. We might get it up to like a 0.7 or something. But that's really going to help our peak power production and also aid in our boost control by reducing back pressure in this housing slightly. And overall, it should be a good little modification. The only other thing I've seen on internal gate housings generally is you get cracking in this area. I would have seeked to remove material here for gate control purposes, but it's already out pretty much as far as it needs to go. I want to preserve the best possible seal I can here and also worry about that jiggle. I don't want it jiggling off and being in some orientation that causes an internal leak. So these turbos spool up real rapidly normally. We're going to sacrifice a slight amount of that spool for a more robust, higher flowing turbine and compressor wheel and housing, and just kind of seek that top end. Let's give a quick polish to our turbine shaft just to remove some of that material transfer. So I'm just going to use a small piece of 7,000 grit paper, using a little dab of oil for lubrication and cooling. And then just very light pressure. Try to spin that turbine evenly in a bit of a downward direction. And then getting to the end here, I'm going to spin it down in the other direction. So just trying to gently buff off that remaining bearing material. We're not trying to change the tolerances here at all, and we may have to do this a couple times. So looking at a single pass, there's still a tiny bit of material there. So off camera, I'm going to do that one more time. Then I'll just hit it with a rag and some metal polish, and it should be gleaming. So after a little buffing, we're ready to go. It's looking great now, a little smoother than factory. So before we go ahead and install this turbine, let's take a look at how these parts compare to the OEMs in terms of mass. So I've got the piston ring on both turbines and the nut. So let's see if we can get this thing to balance on here and get a weight off of it. So 151.79 OEM. $160.22 custom. So slight increase in mass despite our minor slimming in the nose section and reduced nut size, and that's just going to be on account of the thicker blades. Moving on to OEM cast wheel. 44.661. And this is where I would expect there to be a mass reduction. And I guess we're hoping for about 6, 8, 10 grams to make it even. There's been significant slimming through the center section. And also the blades are a little thinner on the front side. $33.25. So let me quickly add all these numbers up, and we'll take a look at our overall weights on comparative rotor groups. So here's the breakdown of comparative weights. Our OEM compressor wheel, we've seen like an 11.4 gram reduction in weight due to our significant slimming of the nose section, which also helps with airflow due to more surface area of blades. So significant benefits on the compressor side. However, we've seen about 8 gram increase in weight on the turbine due to the thicker blade profile, despite our slimming of both center and nut. So overall, we have achieved, a 3 gram reduction in weight, or about 1.5% total mass reduction, which will help with our spool up. However, the thickness of the blades has increased the amount of mass that's further from the center line. So overall weight reduction, however, we've increased moment of inertia, which would be an entire other video. But essentially, just like a longer lever creates more force, it takes more force to move mass away from the center line of a rotating assembly. So overall, I'm going to say there's probably no effect on spool. It's going to be virtually undetectable. But unfortunately, I don't think we're going to gain a massive spool benefit. That being said, we will increase overall flow through both turbine and compressor side at the same spool. So overall significant benefit. Let's go ahead and install our turbine. So first off, new heat shield. And quickly I'm going to check. So lightly magnetic. I got a second rebuild kit here. I'm just going to quickly check our other shield option. Okay. So our second shield is very, very non-magnetic. You know what? They're about the same. Well, I'm going to go with our perceptively less magnetic heat shield with stainless steels, or nickel steels are more resistant to heat than a mild steel. And then secondly, we got our turbine here with the piston ring on, giving it a little rotation in its groove to make sure there's no burrs or anything hanging it up. And now we're going to go ahead, throw a bit of oil on there. And rotating it. While we're at it, let's put a little oil on the receiving groove. Next, some oil down the bearing area. And we're using our classic mix of 5W50 with high ZZDP assembly lube. It's got a bit of stick, but not so sticky that it's going to prevent us from actually feeling what's going on when we spin it. And then just centering that ring as best we can. And trying to slip it straight through without rotating our collar. So I'm hung up on the collar slightly. And this is where it gets a little difficult with these fully balanced units. So normally you could rotate this turbine to get that piston ring to seat, but in this case we gotta carefully budget with our pick to center it. Just lifting in and out gently. So I think it's centered. Shouldn't take a ton of effort. Okay, I'm going to work at this off camera because it's a delicate procedure. But essentially, as soon as you get that ring lined up, it should pop right in, no problem. So just a little bit of back and forth with the pick. It was just that ring was slightly off to one side and I had to bump it in central and then it went right in, no problem. And I'm not going to rotate this much, but it rotates nice and free. We're going to have to give it its spin test once we get the compressor side on. So let's work at that. So for compressor side, we've got our turbine lined up with our other orientation marks, and this is as inserted. It's not been rotated. And what we're going to have to do is heat this guy with the heat gun and then quickly slip it on in orientation. And then I'll heat it up again right before we torque the nut so that it's expanded and won't drag on this central shaft. So let's get heating this thing. So once you got it nice and hot to the touch, slips on no problem, but you got to very quickly orient your turbine and wheel marks. So right there. And now we're going to go ahead and get the nut on there. I'm going to heat it up one more time right before we torque the nut. So first, just a tiny bit of red Loctite. We're not that worried about the nut slipping on this one because of the interference fit. But just a tiny bit of Loctite and then throw that nut home with a hot wheel. So with the wheel hot, I'm going to change my strategy. I'm actually going to move the wheel to where the nut is. Because with the wheel expanded, it's probably going to move with the nut. And now very quickly, .12 M8 on the front and a 12 mil wrench on the rear. So I'm going to do that again. Our nut went further than our wheel, unfortunately, and we've kind of out-tracked our balance mark. So let's try it again. All right, now we've got our nut balance mark slightly behind our wheel mark, and we are going to try to sink it home. So a bit difficult to see here, but we got turbine, nut, wheel. The nut did track again ever so slightly in front of the wheel, but the majority of the mass here is going to be in turbine and compressor, and the wheel is unmodified. It's not ground. So we're going to call that balanced. Let's throw this in some housings and check clearances. Before we throw it in some housings, let's do the old spin test. Feels real good, super smooth, no play of any kind. That's ready to rock. So let's go for front housing. I got the O-ring on the front here. I lubricated it with a tiny bit of synthetic grease. These GT28s, 25s are not super easy to adjust clocking. You have to basically compress this ring and rotate it. So just greasing it up for future likelihood of clocking. But throw our new snap ring over top. And then carefully inserting it straight into the housing. And I'm going to be extra careful here because I don't want to ding up our ceramic coat that we spent so much time and effort on. So I think I got to get a larger pair of snap ring pliers, so I'll be right back. So larger snap ring pliers acquired. I've loaded up the ring into the pliers, and now we're just going to carefully slip that guy on and over, moving it to the area where we've got the best access. And I'm trying to be very careful not to score up our beautiful Cerakote job. Might take a couple adjustments. There we go. So I'll have to clock this at a later date. But our wheel is looking beautifully at home in its housing. Got the heat shield dragging a bit, but sitting straight, appropriate, about a millimeter, half a millimeter clearance to housing. And that thing's ready to rock. So let's sit this in its rear housing and check the turbine clearance as well. Let's throw on the turbine housing next. So just checking fitment for this. I'm going to immediately take it apart again and continue porting. We'll eventually blast and ceramic coat this piece as well. Similar process, just making sure not to drop our turbo and inserting it straight into the receiving hole. Okay, moment of truth. This is where you'll quickly find out if you have a clearance issue. So we're spinning freely. Many times I've made a custom turbine only for it to have a half a millimeter or so of additional blade diameter, just my own mistake in measurement. And then that results in contact that I then have to port out, and it's quite a painful process. So let me throw these flanges on, and then we'll get this thing buttoned up and flip it over, take a look. So checking out our turbine clearance, got plenty of clearance, there's definitely nothing touching, so we have nailed it on the measurements, the blade profiles, and we'll get this thing all ceramic coated and reassembled with a wastegate and everything. Probably wait for another video for that one. So that's going to be it on upgrading a SR20 GT25, or truly a TB25 Garrett turbo. This is all ready to go back into service, but we'll put some coating on that rear housing. Try to take a look at this thing spinning. Yeah, it's great. So real interested to see how this performs. Should light up instantly, make like 250 wheel. And yeah, we'll see if we run into the turbine side restrictions and boost creep issues that are typical once we finish the porting on the rear housing. So if you like that video, or you want to see other Nissan turbo videos, I've got a blown RB25. It's the ceramic turbine wheel plastic compressor variety. We'll be tearing into that pretty soon here. But as always, like and subscribe. We'll see you in the next one.